now I already mentioned a lot of things that we're supposed to understand. Now let's look at one concept here. But before then, let's say we've been given, please, if your camera is on or your mic is on, kindly switch it off. Let's say you have been given a set A, which is 2 comma 4. Your camera or your mic is on, kindly switch them off. And then the set B, let's say is, let's say negative 1 comma 3. And then you've also been given the universal set. Now, mostly on sets, if you see the letter X, it will mean the universal set, except if they've told you it's not the universal set. So X, let's say we've been given that the universal set is 2 up to, let's say, 5. Okay. Now, they asked you to find and show on the number line A intersection B. That's the first one. The second one, let's say they ask you to find A complement union B, and then C, let's say they ask us to find A intersection B complement. Okay, let's find these three and then I talk about other concepts that you need to understand. Now remember, first thing first, you should always represent your sets on the number line. That is very important. Okay, so let's start. We are now, if they've given you a universal set, let me make this, please, when they've given you a universal set, always start with the universal set. So the universal set is from negative 2 up to 5. Make sure that the universal set is present on your number line. Universal set means that is the region in which you are working. You can't have numbers beyond 5. You can't have numbers smaller than negative 2. You are only working between negative 2 and 5. That's the meaning of the universal set. Take this and get it well. All right. You cannot write anything that is going to show any number above 5 and any number below negative 2. So now I'm going to write my set A. Okay, I can write my, before I even write my set A, I can write the inverse set. The inverse set, we can see we are include negative 2. We are also including a 5. That is why it is closed, you can see. Okay, so that is set X. We can put our set A and B. Now we find their intersection. We can say A is from 2. Let's say 2 is going to be somewhere here. And then 4 is going to be somewhere here. Now, am I going to shade at 2 for me to write set A, or I'm not going to shade? Anyone? Okay, no shading. How about at 4? Am I going to shade or not? Okay, thank you. So we shade there. This is going to be our set A. Let's go to set B. Where am I going to shade and where am I not going to shade? Okay, how about at 3? Okay, thank you. So at negative 1, I'm going to shade. At 3, I'm not going to shade. This is B. Now we want the intersection. Intersection means what is appearing in both sets. So meaning between here and here. Like that is where these two sets are meeting. Okay, that region. So I'm going to say for my A intersection B is going to be 2 comma 3. Leah, is that a question? Please, you can go on. Okay, where should I repeat? So if you can see, the set A has been given from 2 to 4. So that is what we've written from 2 to 4 here. And then the set B is from negative 1 to 3. So we have written from negative 1 up to 3. And then we want where these two sets are intersecting or where they are meeting. So that's why you can see where these two lines are meeting. That's the intersection. That's where I've shaded. Is that okay? Okay. Now I've written 2 and 3, but if you can notice, is 2 in the set A? Look at that. It's not. Huh? So is it going to be present in the intersection or not? Okay. It will not, isn't it? As long as a number is not in a set, it can't be part of the intersection. How about look at 3? 3 is not in the set B. Is it going to be part of the intersection? Is it okay? It will also not be part of the intersection. Why? Because it is not in B. So that is going to be A intersection B, 2 comma 3. Is there anyone who has been left out? Yeah, Moses, is that a hand? Please go on. Okay, what determines is the brackets you are using. Yes. So if you see brackets like these we call them open, it means don't shade. If you see these which are looking like a rectangle, this means it closed, it means you are going to shade. Okay. All right. Let's answer B now. I'm going to just remove this and then we answer B. There's a mic that I'm getting. Please, you can switch it off. Unless if you have got a question, just be free and ask. If you have got any question, please be free and ask. Okay, let's answer this one. We want to talk about a complement. So if you see, if they write this, it is the same as writing a C on top. Don't get confused, all right? That's a complement. If you see, is it a comma on top or a C? That means complement. It's the same thing. And complement, anyone, what does complement mean? Thank you. Something that is not part of the set. So let's start with set A. Let's write set A. So set A is starting from 2 up to 4. So we are not including 2, we are including 4. So this is set A. Now I want a complement, meaning I want something outside A. That's the meaning. So something outside A, look at this. Since 2, pardon? Oh, yes, I've not included it. I want to show it here so that you understand now how we use the universal set. Okay, look at this. If 2 is 2 part of the set A, is it going to be outside A? Yes. So since 2 is not part of the set A, meaning that it is part of the set A complement, so we are going to shade here. Okay. And then look at 4. Is 4 part of the set A? Okay, since it is part of the set A, meaning it can't be part of the set outside A, so you open. This is very important. Now, when you do this, now start going outside, start going outwards in both directions. But remember, you can't exceed the universal set. The universal set is starting at negative 2, and negative 2 is part of the universal set, so I'm going to shade that negative 2. And then it is going all the way up to 5, and 5 is part of the universal set, so I'm also going to shade that 5. So this set I've written here is a complement. If they said write on, let's say we had the question D, they said find a complement. It means that the answer for that question D, a complement, is going to be, you can see we are starting at negative 2, we go all the way up to positive 2. But at negative 2, it is closed. At 2, it is also closed. And then we are pausing and then we are skipping. We are starting from 4 up to 5. But at 5 is going to be closed because we have shaded. At 4 is going to be open. Now, what is there? What is between here? There is nothing. So you use a universal set to connect these two regions. So that is how you would have written if they said find a complement. Is this okay? So don't worry if you feel you have to revise. I'm going to post a tutorial. You still go through it again. But what I want you to, is this okay what I've done here? Yes. Yes, that would be. So if at the end here we had something open, it means we would have not used the closed interval brackets there. Okay. Go on. Okay, look at this. The set A has got 2, it has also 4, but then we are not including 2, we are also not including 4. I mean, we are not including 2, but we are including 4. Since 2 is not part of the set A, it means it is going to be outside A. And then if you look at 4, since 4 is part of the set A, meaning that it can't be outside A. That is why at 4 in the complement I have not shaded. And then at 2 in the complement I have shaded. Why? Because 2 wasn't in A, meaning that it is going to be outside A. And then just follow and then write the lines outwards. Okay, from here, because we want to find everything outside the set A, go all the way to where this universal set is beginning. We can't exceed the universal set. And then also in front, go all the way to where the universal set is ending. That is how we ended up with this set. And then when writing, you always know that when you have a shading, you are going to use this. When you have a shading, you are going to use that. Here where you have got no shading, you use this. Here you have got a shading, you use that. Now just put the numbers which are falling on those regions. Here we have got negative 2. You always separate using a comma. And then we are going all the way up to 2. And then here we have got 4. We are going all the way up to 5. Just join these using a union. So that is how we found that. Is that okay? Okay, now we want to find where this set is going to do. We have found A complement. Now, where does it unite with B? So, want union with B. Now, what is the set B? The set B starting from negative 1. Negative 1 is here all the way up to 3. So, I'm going to write that set negative 1 up to 3. Negative 1 is being included, and then 3 is not being included. Okay, this is set B. Now, remember, you want where A complement is uniting with B. Remember, this is union, it's not intersection. Union means combine everything. So we are going to combine everything that I've written in red. Okay. So I'm going to combine this set which I've written in red here with everything. I'm going to combine. But look, here there is nothing here. So you can't combine anything at that region because the sets are not meeting. Think of this, you have got a rope, you have got another rope, and then you have got another set of ropes. I want you to understand this. You have got this rope and this rope, and then you have got this and this. Let's say this is B, this is A. Let's say this at this end it is stuck, at this end it is stuck, even this one at this end it is stuck, even this one at this end is stuck. Between A and B, which one do you think you are able to tie on the middle? Yes, Faith? Okay, it is B. As simple as that. That is how the universal set works. I mean the union. So even if you are talking about union, these two you can't unite them. Same with this region here, you can't unite it because they are not joining. But then at this point they are joining, so you can find the union. That is very important. Okay, so now let's write our set, the union of these two sets. So the union of A complement and B is therefore going to be the smallest number that we have is this number here, which is negative 2. Okay, we are going to close here. Why are we closing? Because negative 2 is part of A complement. And then we are going to move all the way. Look, all this region has been connected. All this region has been connected up to 3. At 3 we have not connected, but look at 3. 3 is not part of the set B, so we're going to use this bracket. And then from that point we are going to continue all the way from what? From 4 up to 5. 5 is being included, 4 is not being included. Just put a union on the middle. So this is going to be A complement union B. That is how you represent that set. Is there a question here? Is there a question? Okay. Yes. Please go on. You can be free. Open your mic and ask. Mhm. Okay, we use this because it is open. On 4, we add a circle which is not shaded. So every time you have got something that is not shaded, you always use this kind of bracket. Yes, if you want, you can draw first on one number line and then transfer to another number line, just if you want to be smart. But then, as long as you end up with something right, it is okay. Okay, let's answer this last question and then I tell you about nice laws which you are going to find a lot of times. Let's answer C. Want to find A intersection B complement. Now, the first thing is A is from 2 up to, so A is starting from here. Look, I've not shaded, and then I'll shade. Yes, that's correct. You can also do that. We'll talk about it anyways. Okay, so this is set A from 2 to 4, and then set B, look, it's starting from negative 1 up to 3. So meaning at 3 I'll not shade, negative 1 I'm shading. This is set B. We want these two guys where they are intersecting, so they are intersecting here. So I can transfer this on another number line just to be smart, to look clean. Okay. So you can see the intersection of the set A and the set B is between 2 and 3. Now let me ask, is 2 going to be part of the intersection? No, it will not be. Thank you. How about 3? Is it going to be part of the intersection? It will also not be because it is open here. So this set I've written is A intersection B. Okay. So we can now turn off our mics. Now we want the complement of A intersection B. After you have found A intersection B, now find its complement. Complement means what is outside. Now, if since 3 is not in A intersection B, it means that 3 is going to be in the complement. So I'm going to shade here and then I'll show going in this direction. 2 is also not part of the intersection, so I'm going to shade here and also show going in this direction. Now you remember the universal set going to the left is ending up to negative 2, so I can't go beyond negative 2. And negative 2 you can see is part of the set, so I'm going to shade. And then going forward, I can't go beyond the 5, so I'll put a 5 here. And 5 is also part of the union, so I also shade. So this sets I've written here is actually A intersection B complement. So then my answer then for A intersection B complement is going to be negative 2, comma 2. They are all going to be closed. Union 3, comma 5. So this is going to be it. Is this okay? All right. So having understood this, let's talk about some interesting facts. Now, some other questions you are going to encounter is they can ask you to shade, or they'll give you something that has been shaded. They ask you to write. You need to understand that. All right. So the first thing is let's talk about simplifying sets. This is the most important part. If you don't know this, then you don't know sets. You would have forgotten everything that I've said, but never. This is what we call sets. This is what differentiates you from someone in high school. Okay. The first thing you need to understand is if you get any set A, you intersect it with itself. Like me, and I don't know how I can me intersection me is me. Okay, that's what you need to understand. A intersection A is A. Please write this down. This is the first one. The second one is if you get a set, you take a union with itself. It will still be that same set. Okay, very important. Now, if you take a set, you intersect it with something that is empty. That is a symbol for an empty set. Now, intersection means something common. Is there anything common between nothing and something? Nothing, isn't it? There's no. So if you intersect something with nothing, there's going to be nothing because what you want is to see what is in both sets. Let's say they get, we say those with data, you have got someone with data and someone without data. They say these people are the same. They are not the same. Why not this? Why are they not the same? Because someone has data, the other one has no data. So they are not the same because of that one without data. So if you intersect a set with an empty set, the answer is always an empty set. But if you get a set, you take a union with an empty set. Union means you are combining. If you get someone with a two quater with someone with nothing, you are going to say these two have got a two quater, even if it is only one with it. Why? Because you are combining them. So if you take a union of a set with an empty set, the answer is that same set. Please take this from here. So meaning that if they've given, say, a set A intersection B, they've written like this, and then they say union empty set. What is going to be the answer? Anyone? Yes. Yes, that's how you answer these questions. Very good. Let's say if they gave us A union B, and then they said intersect an empty set, what is going to be the answer? Empty set. Very good. You see how important these laws are. And this is how they are going to they'll ask you something like this: simplify as far as possible. So, meaning if you don't know that, you'll not be able to finish and then you get it wrong. Okay. The other rule that you need to understand, if you have got a set A, you intersect it with a universal set. Now, take note, universal set, you can either use E or you can use U. Now, I don't want to use U because I'm also using U as union. Okay, but just know that you find them the same. Say they get a set A, you intersect it with the universal set. Now, every time you're intersecting two sets, the smaller one will always be the answer. Universal set, say for example, me intersecting the universe. Where is me and the universe meeting? It is me. Okay? Meet intersecting is meeting. Different from union. Where is what is common? If we combined me and the universe, what are we going to get? We are going to get the universe. Union means combining. So union, you always get a bigger set. Very important to understand that also. Okay. So this means these are the rules you need to understand. Let me just write something. This means if I get an empty set, I intersect it with the universal set. I've already written them. What is going to be the answer? I get nothing. I want to see what is common between it with. What will be the answer? It will be an empty set, yes. Okay, just know as long as you have got empty and intersection, it will always be empty. How about if I've got empty set, union, universal set? What is going to be the answer? Yes, the universal set. These rules here are very important. Okay, now let's talk. These are rules. Now let's talk about laws. I've talked about these are rules. Now set laws. There are about four laws that you need to understand. You don't just need to understand them, but you also need to know how to prove them and how to deal with them. Okay. The first one is called the law of commutativity or commutative law. Now, commutative just means if you turn something, the answer will be the same as the way it was. So let's say, for example, 1 plus 2 and 2 plus 1. Are they the same or they are different? It says same. This means that the addition is commutative. Okay. So that means that addition is commutative. And this is the same union and intersection are commutative. So if I say A union B, it is going to be the same as B union A. You also have the law of distribution. We call it the distributive law. Now, the distributive law, let's say if I've got X, open brackets, Y plus Z. Anyone to tell me what will be the answer if I distribute X? Thank you. So this is same if I've got a set A intersection, open brackets, B union C. So what you guys did is there was a times here. You got X, you multiplied with Y. Same, you are going to get this A. Now the times here is being represented by intersection. So you are going to get the A, you are going to intersect with the B inside. You close. Okay, and then what you did is you got a sign on the middle. So again, get a sign on the middle, which is the union, and then again get the A with the intersect. Now intersect with C. So this is a law of distribution. It is a very important law. This means I can give you this part for you to go back to this end. So if you don't know, you might struggle. But now you know, so you'll not be able to struggle. Is this okay? Okay. Now, I was saying the law of associativity, you only use it when you are talking about the same sign. Let's say you've been given a set A, union the set B, union C. So you can find the union of the last two sets, and then the answer that you get, you find the union with the first set to be the same as you getting the union of the first two sets, and then the answer you get to take the union of the last set. That is the law of associativity. It will be the same if I was using intersection. Okay, the same. Is that okay? So the law of associativity works only when you are talking about the same signs. The same signs, just. So for example, if I say 1 plus 2 and then plus 3, it is going to be the same as me first saying 1 plus and then I say 2 plus 3. Do you get now? So that is the law of associativity. You always deal with two things at a time. Now, the okay, don't worry, you find us. Okay. So the other law I want you to take note of is De Morgan's law. Now, De Morgan's law, if you are having A intersection B, so don't worry, at any point you are behind, you catch up. If you're having A intersection B, you can see there is a complement outside. You can distribute the complement to the inside. Becomes A complement and then B complement. But every time you distribute the complement, always make sure that you change the sign on the middle. Always change the sign. If it was union, becomes intersection. If it was intersection, it becomes union. This is the basis of proving things. Okay, very, very important. Have we gotten this? I should just show some bit of examples and then we are good. Okay, let's talk about proving laws now. These are the questions we are going to find. Simplify the following. Simplify as far as possible. If that is a hand for a question, please you can go on and ask. Or maybe it was just pressing without knowing. All right. So here is a question. They've asked us to simplify as far as possible. X union Y intersection X complement outside. Now, if they ask you to simplify a set as far as possible, the meaning is you should not see the same letter two times. You can see, I can see X here. I can also see X here. As long as I can see the same letter two times, it means that I've not simplified. So how do you go about this one? The first thing is you get a complement which is outside. You distribute to what is inside. So I'm going to get this complement, I'll distribute it to the first thing given, which is the X. And then I'll get also the Y intersection X complement. I also distribute the complement to it. So I'm going to take this as one thing, the entire of this as one thing also. Okay? So make sure that you get that. You can see I got the entire of this thing and then I distributed the complement. Now, if you don't get this, you are going to struggle in your test one, you struggle in your exam because these are things which come. Now, from the De Morgan's law, look at the sign. There was a union on the middle. After I distribute the complement, what do you think is going to happen to the sign? Okay, very good. It becomes intersection. Very good. Now, after that happens, the next thing is I'll start dealing with this part alone. This part alone. Hope you can see that. Okay. I'm going to distribute that complement, which is so it becomes x complement intersection. I'll distribute the complement. So we're going to remember this complement to go to these guys which are inside the two of them. So what we are going to have is this. We are going to have y with a complement, and then we are going to have x. Remember x as a complement, so it will have another complement. What will happen to this sign here? It becomes a union. Very good. Now, other laws that I want to talk about, other rules. If you have got x with a complement and another complement, the two complements cancel each other. So it just be x. Okay, that is the first thing you need to take note of. Again, if you have got a set x, if it intersects its complement. Now, remember a complement is something outside. Is there a point where the outside of the house and the inside of the house are going to meet? No. So if you intersect a set with its complement, the answer is an empty set. Okay. And then if you get a set, okay, thank you. If you get a set, you unite it with its complement. Now, if you get what is inside with everything outside, it will give you what? Very good, Razia. So it will give you the universal set. Okay, that will be the answer. This is what you take note of these three. So continue. This will give us x complement intersection y complement union x, because those two complements are going to cancel out. Now I'm going to use the distributive law at this point. Look at this. We have got x complement. Okay, we'll distribute with what is here, more like a multiplication, the same way we do a multiplication. So that is going to give us x complement intersection y complement. I'll put this in brackets. Don't forget you get a sign on the middle here, union. And then again get the same x complement intersect distributed now with this guy which is at the end. And then that is going to give you x complement intersect x. Now this again will be x complement intersect y complement union. Look at this. What will be the answer here? What is x complement intersect x? Empty set. Very good. Remember the first rule that we talked about? If you take the union of a set with an empty set, what will be the answer? Remember we said if you take the union of a set with an empty set, the answer is just that same set. So it will be x complement intersection y complement. So this is the answer. If you want to write it in another way, you can use the De Morgan's law. So this is the same as x union y in brackets, and then you put the complement outside. These two guys, if you write any one of these two, you get it correct. You can see I don't have the same letter two times, so I've simplified it as far as possible. Is this okay? Very good. Let me just give another example. We don't want to see any complement. Now, another way they could have asked this is they could have given this and then could have said shade. So it means you can't shade direct. All right, they will say shade in a Venn diagram. You can't shade direct. So the only way you can shade is after you've simplified. So now let's try to shade on in a Venn diagram. So this is, we only have the sets x and y. So let's say this is x, this is y. And look at this. We are talking about x union y complement. X union y means get everything in x and everything in y. Okay? That is what we would have shaded. But then we want what is outside. So we are getting what is outside x and y. So this is the shading for this set. It is x union y complement. Let's look at another example. Before I even talk about that example, please go on. A subset is going to have something else. So yeah, it will be something else. Okay. If you hear they say two sets are disjoint sets, let's say A and B are disjoint sets, just know that if you take their intersection, they'll give you an empty set. So if they say set A and set B are disjoint set, it means that on a Venn diagram, those sets are like this. They don't intersect. Take note of that. Disjoint. They don't have an intersection. They don't intersect. Okay. Let's say we want to simplify. They have given us that A is a subset of B. Okay. And then you want to simplify the following. Let's say I want to simplify A intersection B union B union A complement. Simplify as far as possible. Simplify as far as possible. This is our question. These are interesting questions you'll be able to find. Okay. Who can tell us what should be the first thing that we are going to do? Okay, thank you. Now, this one I've written here is a subset. If I write this is known as a superset. Okay? Shouldn't confuse you. A is going into B. Here it means that B is the one going into A. So A is a superset of B. A is a subset of B. Okay. So the first thing first, we are going to distribute a complement. So we are going to have A intersection B with a complement, and then B union A complement with another complement. What will happen to the sign? Thank you. It becomes an intersection. Good. The next thing I'm going to let me okay, I should have the let me write this one the same way. It is A intersection B with a complement and then intersection. I'm going to distribute this complement. Let me just actually distribute the complements both sides. Okay. So I'm going to get this complement, I'll distribute to the inside. So I'm going to end up with A complement. What happens to the sign? Is union now, B complement. And then here we still have intersection. Now let's also distribute this side. If you distribute, what are we going to have? Okay, now for goodness sake, let me change here. Let me put intersection. Okay, for goodness sake, there's something that I want to do. So if we distribute the complement, it will become what? Union A, isn't it? Is it a complement? No. Good. Okay. At this point, this is where I want you to understand things. Please, you can switch off the camera, and if there's any mic, you can switch it off. Okay. So now remember we had mentioned about the law of commutativity. Here I'm beginning with a B. I want in the other set also to begin with a B. So by the law of commutativity, I can also write this as B complement union A complement intersection B complement union A. Is this okay? Now, following the knowledge, remember the distributive law, remember? So if I have got xy plus xz, it means I can factorize out x, isn't it? Do you remember this? Okay, that's the same knowledge. I have got B complement union. I also have B complement union. So I can factorize out B complement union. And what I'll remain here is I'm remain with A complement. And then get a sign on the middle, which is the intersection. And then here I'll remain with the A. If you want, you can distribute, you go back on top. So this again gives us B complement union. Now, what is A complement intersection A? It's an empty set. Very good. And what is B complement union empty set? M empty set is B complement. Very good. So this is going to be the okay. This is going to be the final answer. Is this okay? Now imagine they asked us to shade. Is that a question? Yes, please go on. So you'll not be given full marks. If the question is 5 marks, they might give you 3 or 4. Others, actually, other markers. This is where why people feel other markers just use the marking key because themselves they do not know the course. So what they'll do is they'll just be marking the final answer. So just goes to the final answer as long as it's not the same, they'll mark you wrong. Unless if they've clearly stated in the marking key at this stage give these marks, at this stage give these marks, otherwise that's how people end up failing because of just something useless at the end. Okay, please, if you have got another question you can ask. Okay, thank you. So we could We could not have factored out A because in one bracket you have got A complement, in the other one you have got A. So they are not common, so you can't factor them out. Alright. So let's say now they wanted us to shade this set. The first thing you need to look at is this. A is a subset of B, meaning that B is a bigger set and then A is inside. So we want B complement. So B complement is just everything outside B. Okay? That is B complement. That's very important. Okay? So let's say they gave us a set like so. A is a subset of B. But then you want to find A complement intersection B. How can you answer this one? The first thing, don't forget that A is a subset of B. So let's write B. B is a bigger set. And then you have got A inside. So A complement means what is outside A. Now it should be outside A, but it should be in B. That's the meaning. Outside A, but should be in B. So the answer would be this region. If it was the other way, let's say the same question, this is the set B, this is the set A, but it was A complement union B. The meaning of this is you want what is outside A. What is outside A is this. Shade everything what is outside the A. That is outside A. Now, union B. Union means also shade B, the entire set B. So also shade the entire set B, including that part which is inside A. So meaning that the answer would be the universal set. Okay, when you are shading. You need to understand these okay, because they are very important, and if you miss them, if they come, to be very bad. Hope we have gotten it all. Yes, Paul. Okay. For the sake of understanding, let me give one more example. Say they asked us to shade A complement union B. How do you shade? A complement means everything outside A. So this is what is outside A. Okay, like that. Everything outside A. Everything outside A. This is A complement. But then we want where it is union B. Union means also shade B. So also shade B, including that part which is in A. So this would be the set. Now this would be different if they asked us to shade A complement intersection B. Let's say this is A, this is B. A complement intersection B means shade what is outside A, but it should be in B. So you are shading what is outside A, but it should be in B. So this is the region we would have shaded. So you see the difference between these two. That is how you do it. Is that okay? Is that okay? Yes, please go on. Okay. Can you say again what you've said? Okay, if A is a subset of B, you shade B complement union A, isn't it? So A is inside there, B is outside here. B complement means everything outside B. So we are shading that region outside B. Union A means also shade the set A. So also shade the set A. So this would be your set. Is that okay? Okay, let me just add for you for the understanding sake. Let's say they are this the same. A is a subset of B, but then they said shade B complement intersection A. B complement intersection A. Now B complement intersection A would mean shade what is outside B but is in A, and that's not possible. So for this one, the answer is itself. You can't shade. There's nothing outside B, but it is in A. Okay. So for B complement intersection A, for such a diagram, it is just itself. There's nothing to do to it.